Hey everyone, and welcome to the second episode of Demistyfy shaders in maxmsp. In this second video we're going to get hands-on with some actual shader code, and we're going to start understanding how shaders work in general and especially in maxmsp. So what we're going to do is to recreate the shader that allows us to render this triangle with three different colors on the screen. As you can see, the colors are interpolating into each other. So at the moment, this shape is rendered with a GGL mesh, to which I just sent a matrix containing three different vertices value. In fact, as you can see, the matrix has three cells, type flow32 has three planes, because every vertex has three values, x, y, and zeta, to set its position. And these values are set through the setCell1d message. So here you can see at cell at index 0, I'm sending the vertex position minus 0.8 for the x, minus 0.8 for the y, 0 for the zeta. At vertex index 1, I'm sending the vertex that is here, so 0.8 on the x, minus 0.8 on the y, and then 0 on the zeta axis. On the third cell, we are setting the values here for the vertex at the top. Then we're also sending a matrix that fills the color array, so to set the colors associated to those vertices. And in this case is a 4-plane matrix, because as we know in OpenGL, colors have 4 components: red, green, blue, and alpha. So here at the cell at index 0, I'm sending the color red, at the cell at index 1, the color green, and the third cell, so the cell at index 2, I'm sending the color blue. Great. So this is already rendering this shape, this triangle. As you can see, I'm using draw mode triangles for the GGL mesh, which means it will take these three vertices and draw them as a triangle. And then I'm using smooth shading 1. If smooth shading was set to 0, as it is by default, it will not interpolate the values between the three vertices, but it will just use the color from a single vertex to cover all the three vertices. Instead, if we say smooth shading 1, it will now interpolate the values between the single vertices. Great. So as we said the last time, in OpenGL there is always a shader that is rendering shapes, and in GL3 we can actually see this shader by sending a message to the shape we are rendering, get GL3 shader. So if I click on this, this is the default shader automatically created when I rendered the shape in this configuration. And now we're going to reconstruct the shader from scratch in order to understand how this works. So let's give it a try. So first of all, let's create the object that will allow us to attach the shader to the shape and to also read a shader file from our PC. So the object is called GLSL, as we saw in the previous video, and it must render to my context, which is called shader world. It needs a name of a shader file, so the file doesn't exist yet. I'm going to call it my first shader.jxs. As you can see, we get an error that this file doesn't exist, because indeed it doesn't exist. And then I got to give a name to this object, to the shader object, which I will call my first shader, exactly as the file. I don't have to call it as the file, just an easy name to remember. So now if I want to attach this shader to this GGL mesh, I have to modify the shader attribute of the GGL mesh. So I will call it my first shader. Good. If I click on load bang, you can see that the shape is rendered. If I double click on the GGL shader, it will open the shader file as it is at the moment. Now this is a bit too complex. We don't want to start with the default shader. We're really going to start from scratch. So I'm going to recreate this shader on a text editor. My text editor of choice is Visual Studio Code. So I'm going to open it, I'm going to create a new file, and I'm going to save it in the same folder where my patch is. I will just choose all files, and then I save it like as my first shader.jxs. Great. So I have created this file. Now if I recreate the shader object, you can see that it gives me an error because I cannot just read this file. But if I double click on it, it will open the file directly in Visual Studio Code, because this is my editor of choice that I've set in the options of Max. Great. So we can now start create our shader. So we will create it really from scratch. So when we create a shader file in maxmsp, we always need at least 2 types of different shader programs. One is called the Vertex Shader, and the second is called the Fragment Shader. So our Vertex Shader is going to do only one thing. It's going to transform from object space into screen space. Now, object space is the coordinate system in which our object is represented. So when I say minus 0.8 here for the x, I'm representing those coordinates in object space. I'm talking about those coordinates in object space. Now we need to transform this into screen space, which means we are going to transform this minus 0.8 into a pixel coordinate that is then used by the pipeline to render the pixels on our window. So this is the only thing our Vertex Shader will need to do. While our Fragment Shader will do also only one thing, which is to set the color for the pixels that form the shape. So the value of all these pixels here that represent our triangle is decided in the Fragment Shader. So we are going to do that in our Fragment Shader. Great. So before we can actually write the shader code in our shader file, we need to create something that is called the JXS wrapper. So in Max, in order to use a shader, we have to wrap it around some XML sort of tags structure. But before we create our wrapper XML structure, I'm just going to write the content of the main function of the Vertex Shader and the content of the main function of the Fragment Shader. So let's do it like this. This is going to be our Vertex Shader. So when we write a shader, we always need to create a main function. This is the function that is going to be called by the application using the shader. So our final function, so transform the vertex position actually from object space into screen space, is going to happen into the main function. So it works like this. Void is the type of return of these functions. If this function doesn't return anything, we just say void. So it doesn't give us back any data. And what happens here is that we need to set the GL position variable. So the GL position variable is simply a variable that is built in GLSL, and we have to write to it in order to send the data to the next stage in the pipeline, like we saw in the previous video. So this is a variable that it's write only, we can only write to it, and to this we have to write the position of the vertices in screen space. Good. So GL position is equal to the model view projection matrix multiplied by the position in object space of the vertex, because the vertex shader operates on the single vertices at once, as we said in the previous video. So we have to create a vector 4 that contains the position of our vertex in object space, which is a vector 3 because we said that to set the position of a vertex we need 3 coordinates, the x, the epsilon, and the zeta. So this is a vector 3, our position, and 1.0 is just a number that we need to fill in the fourth place of this vector in order to have a vector 4, because this model view projection matrix is actually a matrix, not in the jitter sense of matrix, but in the mathematical sense of matrix. So it's just a matrix that will apply a transformation to our vertex position. So this transformation will transform the position of the vertex from object space into screen space. So the matrix will apply a transformation to a vertex position in order to bring the vertex from object space to screen space. So basically the coordinates of the vertices in our rendering window. Good, so this is all that the Vertex Shader must do. Now let's create the main function of the Fragment Shader. So again, we have to create a main function, so void main. This is always going to be called by the main application, in this case maxmsp. And in this case, the variable to which we have to write, we can call it as we want. We just have to create an output variable. So this is for the GL3 syntax in Max. I'm not going to cover the GL2 syntax because it's anyway outdated. So in the GL3 syntax in Max, we have to create an output variable. So write out, this means this variable is going to be in output, is of type vector 4 because as we said in OpenGL, the colors have 4 components, red, green, blue, and alpha. And we are just going to call it, for example, output color, something like that. Now we have to write to this variable in order to send the color in output for the single pixels. So the color that we send as an output is going to be the color that we pass through the matrix to the GGL mesh. And this color, we will pass it from the Vertex Shader to the Fragment Shader. So in our Vertex Shader, we need to create a variable, call it, for example, outVertexColor, and assign to this variable the color, which is a property of the vertex that we get inside the Vertex Shader. So this will be for example, this we can call it vertex color. So at the moment this will not work because first we are missing all the JXS wrapper and we don't have this vertex color assigned as an input, but we're going to make this work. So basically here we need to assign to the output color this variable that in the vertex shader we call it maybe out vertex color. Let's actually do it. So in the Vertex Shader, let's actually create this variable as an output. So output, as we did it in the Fragment Shader to send the output color. So this is called out vertex color and is of type vec4 because, as we say, the colors has 4 components. And now in the Fragment Shader, we have to create an input variable which is of type type vector4, and this is called in vertex color. Good. So this is how we pass variables from the Vertex Shader to the Fragment Shader. So the Fragment Shader has an input variable in this case, which is the input vertex color, and it's outputting a variable to the pipeline that then will draw it to the screen, which is called out color. So good, this is basically all we need to do. Now this will not work because we need to create a JXS wrapper around these 2 functions in order to make them work. So let's actually start and create the JXS wrapper. So first of all, we need to create a tag called jitter shader. And then we can assign a name to our shader. For example, I will call it my first shader. It doesn't need to be the same name of the file or anything. It's just for us. And then we can create a description if we want. This is optional. And we can, for example, write our first shader tutorial or something like that. Then we can close the tag. So the description tag is now closed. Good. And now we need to pass to the Vertex Shader the position of our vertices, basically this position variable. So we need to pass it as a parameter. We have to give it a name. We already called it position. So this position is a string here, as you can see, for the attribute name of the parameter. And then we need to give it a type, which in this case is vector3, because our position is a vector3, as we said, it's 3 component x, y, and z. And then, since we are not passing this variable manually, but is actually passed directly from the application to the shader, we need to say state. So it means from which place are we getting this variable? And we are getting it from the position value of the vertex, because a vertex has a lot of different properties, for example, as a color, as a position, as a texture coordinate, and so on. And in this case, we say we are getting it from the position property of the vertex. Good. And then we need to declare also the color, so the vertex color. So we say we call it this vertex color. And this is of type vector4, because we say colors are type vector4. And this also comes from the state, because we are passing not it manually, but through a matrix to the GGL mesh. And this we get from the property color of the vertex. So we say the vertex has several properties. This is the color property of the vertex. Now, how do we know how many properties has a vertex? Well, if we go into max references and we look for GLSL or something like that, and we go into documentation, there should be appendix C, the JXS file format. And here you can see some more property of the vertices. So the position, the normal, the tangent, the bitangent, but actually there is also the color. So this is the appendix C is a good place to look for resources on what we can actually access in a shader file. So this is all we want to pass to the Vertex Shader. Now we need to create another line, another tag called language, which means which language are we using, because there are several languages to write shader. We are going to use GLSL. This is the language we are using. And then we have to set a version. So since we are using a max OpenGL with GL3 set, we need to use version 1.5. Good. So this was it. Now we need to bind those parameters to the actual shaders programs that we wrote. So either to the Vertex Shader or to the Fragment Shader. So we need to bind the position to the Vertex Shader, because as we saw is being used inside the Vertex Shader. So we need to write the tag bind, the param, so the name of the param, which is called position. And then we have to say to which program do we want to bind it. And we say Vertex program, so VP. Good. Then we have also the model view projection matrix. We also need to bind actually to the Vertex Shader. This we actually need also to declare as well. Sorry, I forgot about it. So param name. So this is also, let's call it model view projection matrix. This is of type, as we say, this is a matrix with 4 rows and 4 columns. So in GLSL, this is called a mat4. So the type is called mat4. And this is also comes from the state, so we don't set it manually, but comes directly from Max, from the application. And this state is called model view underscore projection underscore matrix. Good, so close the tag. And you can check this also in the reference. There's written which kind of matrices can we access in the shader file. And you can see that we can access the world matrix, the view matrix, the model view, and the model view projection matrix, which is the one that transforms the coordinates from object space into screen space. So this is the one we need. As you can see now, it's giving us a lot of error because the shader is not complete at all. That's why it's not gonna work at the moment. So model view projection matrix, I think I wrote this correctly. Good. So we need to bind this as well to the Vertex shader, the Vertex program. So model view projection matrix, to which program? To the Vertex program. Good, and close this tag. Good, and then we need to bind also the color. So let me actually put it above the model view projection matrix. So bind param equal vertex color and to the program, also to the vertex program, because we're going to pass it from the vertex program to the fragment program. So here we need to create an input variable, as we did in the Fragment Shader, which represents first a vector 3 that represents our position, then a vector 4 that represents our vertex color. Great. And then we have our output variable that represents the output vertex color. Great. We also need to set the model view projection matrix. Now this is a different variable. It's not an in variable. It's actually called a uniform, and that's because the position and the vertex color are different from every vertex. This means they are actually attributes for the vertices, while the model view projection matrix is the same for all the vertices in the shape. This is why it's called uniform, because it's uniform over all the shape. So this is of type vector mact4. And we can just declare it like this as a uniform. Good. So now we will be able to use it inside our Vertex Shader. Now, actually, after we finish binding the parameters here, we need to create another tag which starts our Vertex program. So this is our program tag, which means here starts our program. So this is our Vertex program. So we said we call it VP, it's the name of our program, and is of type Vertex. So this program that we are writing here is of type Vertex. It means is a Vertex Shader. Then we need to write this funny line, which is a tag that goes like this, exclamation mark, see data. And then it's not closed like this, but it's actually open. It's like if this is opening an array here called see data. Great. And then we need to go at the end of our Vertex Shader and we need to close it by closing these array brackets and then closing the tag here. Good, then we need to close the program tag. So program is close the tag. Good, and this is it for our Vertex Shader. Now we need to create a couple of tags for our Fragment Shader. So again, the program tag. So name, this is going to be FP, it's the name of our fragment program. And this is of type fragment, because it's our Fragment Shader. Great. So a Fragment Shader, as we said, is the one responsible for setting the pixels, the color of the pixels, which in GLSL are actually called the fragments. So the pixel and fragment is the same. So this is our fragment program. We need to write again this funny line. Let's actually copy it from here above. Paste it here. Great. And now we need to close this with again these two square brackets, and then we need to close the program tag. Oh, and I think I closed it incorrectly here above. In fact, it's not like this, but /program. Exactly, this is how we close a tag. And then we need to close the language tag, because you remember we opened this language tag here and we never closed it. So we need to close it down here, so language. And then we need to close the jitter shader tag, so /jitter shader. The jitter shader tag was the first tag that we opened. Good. So I just saved it and it's giving me some errors. Out can't be used with non-varying out vertex color. That's because I forgot to add this line as the first line to our Vertex Shader. It's called a pre-compiler line or something like that, which starts with this hashtag. So hashtag version, we need to say that this is actually the version 330 core of the GLSL programming language. Otherwise, it's going to use an older version which doesn't support these in and out keywords. So we need to do the same in the Fragment Shader version 330 core. Good. Now it's working. I just think that the out variable here and the input variable here should actually have the same name. So I'm just going to replace in vertex color with out vertex color. Good. And it's working. Great. So we completed a bit in a rush, but we completed our first shader file, our first complete shader program from scratch. So we are going to go over all this stuff a lot more in details in the next videos. For the moment, I just wanted to give you all the tools you need to create your own shaders, starting messing up with your shaders. Just to make a little test, let's just set a different color for all the 3 vertices. So for example, the color red here. And as you can see, it's drawing the wall shape in red. So yeah, this is working. This is completely working. Otherwise, it's just going to interpolate the colors that we passed through the matrix color in the patch. So great, yeah, I just wanted to give you all the tools you need to start playing around with shaders. And I hope this was not too confusing. Now, if you have any questions or requests for the next videos, I'm all ears, just let me know in the comments. And you can also, of course, check my Patreon to get patches and to get direct connection with me on Discord. And in any case, thank you very much for watching, and I hope this didn't scare you too much, and I hope to see you in the next video. So have fun and see you soon. Ciao.